Hello everyone, welcome back to my channel. My name is Atul. So this is chapter 2. In the chapter 2 we will be learning what is Kubernetes, what is the benefit of Kubernetes. So don't worry about this one big theory. So we'll be learning one theory one by one and we'll be just learning from theory and we'll be doing some more practicals in coming sessions. But this is the theoretical session. First of all, we have to understand what is Kubernetes and what is the benefit. So let's understand about what is Kubernetes and we'll be starting with a basic definition. So what is Kubernetes? Kubernetes often known as K8. So whenever sometime people will say it's K8s. Okay, so K8s is an open source container orchestration platform. It's used to automate the deployment, scaling, and management of containerized application. Okay, so this name says open source container orchestration. Open source container orchestration. So container we already discuss and orchestration. Orchestration you can say like automation. Okay, and platform used to automate the deployment. This is a platform which is used to automate the deployment. So deployment will come on the new next slides. But you can say like a number of servers available right now. So it's used to automate the number of servers available to serve the application. And it's scaling. Scaling will be discussing in this one. And management of containerized application. So containerized application will be discussing. It used to simplify the process of running and managing application. So this is the way, like with the help of Kubernetes, we can simplify the process of running and managing application, specifically those built with microservices, by automating tasks like deployment, scaling, and resource allocation. So first of all, let's move a little bit bottom, then we'll come to more about Kubernetes. So in a very short manner, Kubernetes is an orchestration platform which is used to manage the application by in which we can get scaling, deployment, and managing of application in ease fashion. So this was originally developed by Google, and later on it was donated to CNCF, Cloud Native Computing Foundation. Now let's take an example like what is Kubernetes? So suppose you are a head chef. Think of Kubernetes as a person running a huge restaurant kitchen. Suppose Kubernetes is a person and it is running a huge restaurant, and too many customers are coming, they are having their food and going. And container as a cook. So whenever more customers are coming, more cooks are coming. And Kubernetes makes sure everyone cooking at the right dish. So when more customers are coming, suppose taking an example of 100 customers are already consuming food and 1,000 more comes in. So what will happen? We won't be able to serve it. So some more cooks are required. So what Kubernetes will do? Kubernetes will call some more cooks and they will start working and they will produce the food, they will cook the food and serve it to the right customer. Right customer, right dish, right cuisine. So this is what it says. No one's lacking and more cook jumps in when crowd shows up. All without the head chef, you are stressing out. So without Kubernetes or you guys will be stressing out, Kubernetes will find out who is the best cook, who is the best job to perform. Let's customer let's consider as a job. In case of more customers comes in, more cooks comes in. So here cook we need to compare with a container or you mean to say pods. So we have too many points to discuss. What is containers, what is pods, we'll be discussing in the next couple of minutes. So, and what are the benefits of Kubernetes? So, what are the benefits of Kubernetes? So, last container orchestration, scaling, self-healing, load balancing, and resource management. So, first point is container orchestration. Let's read the definition of it. Kubernetes manage containers, lightweight portable unit that package an application and its dependency. So what is Kubernetes? What Kubernetes manage? Kubernetes manage containers. And what containers contain? Lightweight portable unit of package and application and its dependency. So you can say like in a container, this is a container and where an application, let me draw some more diagram, where dependency and application. Okay, so this is like a container and application. Okay, so here like the dependency Kubernetes managed container. So this container contain application and dependency, lightweight portable unit that package an application and its dependency across the cluster of machines. So there will be too many machines will be there. It decide where to run. Suppose we have 10 clusters or maybe the 10 servers, where to run that job. Suppose a case when Amazon, some discounts are there, so people are coming. So multiple people will be running that app, Amazon.com. So where those job will be going forward. So that will compute power they will be receiving. Okay, and scaling. Okay, before moving to scaling, self-healing, load balancing, let's move toward. But before that, let's complete point one, like container orchestration. So container orchestration is something like instructor, you do this, you do that. So this is a violin instructor. So all violin guys are just learning and they are waiting for instruction of this violin instructor. Whatever that this violin guys will instruct, everyone will be doing that one only. So here Kubernetes also same. Whatever the Kubernetes controller will be guiding, pods will be doing the same. So here pod, I'll be discussing what is pods. So there are some points which we need to discuss before. So I have created some good diagrams for you guys to learn it easily. So let's learn about so what is Kubernetes node. Sometimes people will say Kubernetes cluster. So what is Kubernetes cluster? What is Kubernetes node? What is worker node? What is master node? What is pod? What is container in pod? What is Kubernetes cluster? Okay, so we'll discuss about one by one what is Kubernetes node. Okay, so the one let's talk about three servers. So server one, two, and a three. So we have three servers, and suppose this is a master. This is master server. This is worker 01 and worker 02. Everyone having their individual IP. These are the physical boxes. Okay, on the physical boxes, suppose our we have installed a master nodes, and these are the worker nodes, or you can say worker nodes are mostly called as a slave node. So environment is like master and a slave nodes. So in case if everything is covered, then this part is called as a Kubernetes cluster. Okay, in case someone say what is master node, so master node is this one. Or in case someone ask what is worker node, so this is a worker node. This is a worker node, worker B, or you can say worker 2. Okay, what is pod here? So that's a very interesting and very important topic. What is pod? Okay, so let's talk about pod. What is pod? So this is Kubernetes pod. This is Kubernetes pod. So here we can see earlier we have seen about the concept of container. So the container is this blue box. So this one, this green box, this is called as a pod. This one is called as a pod. So in this pod, we can say like application we can install inside this container or this pod contain the basic libraries, whatever libraries are required to run an application. And every pod having their own IP. You can see like 192.68.0.5, 192.68.0.6. So every pod have their individual IP. So here like this one blue one is a container. So that upside we have seen the container. So this one we have discussed earlier. So this blue box is called as a container, but this one green one is called as a pod. This one is pod A. The green one is pod A. The blue one is container. That this container. So okay, so let's discuss about this green one. Will be discussing here. So this pod. So what pod contains? So pod contain Ethernet card, their IPC, their mount point, link, their networking, and this one. So this is a container where our application runs in. In case if we go with a microscopic view, then it's a container. So what all it will contain? It's contain a Ethernet card, volumes, and libraries. But here, this is a Docker container, and here every pod having their individual IPs, and one pod may have a multiple containers as well. But most of the cases, like individual containers, two containers are not required. Exception are some more cases, but most of the time, one pod runs with a one container. Okay, so Kubernetes node. So any node is called as a Kubernetes. In case of Kubernetes installed, that is called as a Kubernetes node. And a worker node, this is a worker node, and a master node, this one will be calling as a master node. What is pod? That is we discuss, and this is the way like a pod looks like. There's a Kubernetes pod, one pod A, pod B, pod C, and a pod D, and Kubernetes cluster. So this is we already discussed. This entire cluster is called as a Kubernetes cluster. So here in the right side diagram, we have see like a one is this as a four server cluster, one is a master node, and another with a cluster and with a worker node. So here it's a four node cluster with one master and a three worker node, a worker node one, a worker node two, and worker node three. This is all about worker node. So now let's go again. Okay, so now container orchestration. Kubernetes manage container across a cluster of machine. It decide where to run them. So here Kubernetes orchestrator will decide where to run. So here master is the one who will be managing the jobs. In case of more jobs are coming, so where to execute. So master one having a two option, worker 01, worker 02, where to execute. So it will be checking what their disk pressure, their CPU pressure, their memory pressure. On behalf of it, it will assign the job or means like port to worker 01 or worker 02. Okay. So across the cluster machine, it decide where to run, handle them life cycle, and ensure they're running as intended. So it is making sure that pod should be running in a proper fashion. Now let's move toward the point number two, scaling. Since we already learned the pod, so pod is a single identity in the Kubernetes cluster in which application is running. So this is a pod. So scaling, let's move toward scaling. Suppose a case when in a one server or in one worker node three pods are running. So our application, three replicas are running. Suppose one replica in for application A, three replicas are running. Our traffic increased. So what will happen once we will be enabling automatic scaling in Kubernetes and pod will increase. So when a customer increase, our pod will also increase. So this is like is calling as a scaling. Scaling means adding some more pod. And secondly is a self healing. What self healing means? Suppose a case we having a three pots and this pot dies because of some reason. So I've made it a red color. And suppose this pot die because of some reason. But Kubernetes having a responsibility of self-healing. Okay, so self-healing means pod. So suppose this pod dies and this pod will automatically repair and a new pod will generate. But its IP will change. So this will be, it's not like same person which is taking the medicine and will be, but this pod will die and another pod will come. Or you mean to say another person will come to do the same kind of job. And the load balancing. So we'll be using services ingress to expose our application to external world. So whenever we create an application, so we need to add some resources like load balancer or ingress so that we can expose our application to the external world. So we'll be discussing more about load balancing and second, the last point is the resource management. And with the help of resource management, we can customize the resources. Like for a pod, we will be able to define how much RAM or how much CPU is required for individual pod. So this is all about our application or means like a Kubernetes application and its a benefit. So let's move toward the next lesson. So just pausing it for now and thanks you for watching and have a wonderful day ahead.